Welcome everyone. In this lesson, we're going to learn how to balance what we call redox reactions. First, in this video, we're going to learn how to balance using a technique under acidic conditions. Here we have 7 steps. It's a very organized process. We start by assigning oxidation states. And then one of the key things we're going to do is we're going to separate the reaction into 2 half reactions. One will be the oxidation half reaction. The other will be the reduction half reaction. Now, since we are under acidic conditions, what that means is that we have unlimited amounts of acid, represented as H+, and water. So these are the things that we have at our disposal. So the rule goes like this. After we separate into 2 half reactions, we're going to balance any element that's not hydrogen or oxygen, and we're going to follow this exact order. Then we're going to balance oxygens by adding water to the opposite side. And then after we add the water, we balance the hydrogens by adding hydrogen ions on the opposite side. And I'll take you through the steps in a moment. Once the elements are balanced, in a redox reaction, we also have to balance the charges by adding electrons. Once the elements and the charges are balanced, then we have to multiply one of the half reactions by a factor, if needed, so that both half reactions have the same number of electrons. And after that, once both half reactions have the same number of electrons, we're going to add the 2 half reactions together, and that will complete our answer. And then we can always verify by checking that all the elements as well as all the charges are balanced. Because at the end of the day, we have to conserve not only mass but charge as well under the law of conservation of matter. So here we have our first example. This is a redox reaction. And step number 1 is to assign oxidation states. Now the solutions are listed here. I'm going to show you how this was done. If you recall from a prior video, monoatomic ions, their oxidation states are equal to their charge. So that iron is +2, this one's +3, manganese is +2. I'm equaling it to their charges. And then to find this one here, we can treat manganese as X since we don't know the charge. Now, there are 4 oxygens. Oxygen is usually -2, and because there's a charge, you're going to equal it to a -1 charge. And when we do the algebra here, and we are solving for X is going to be -1 + 8. In other words, X will be 7. And as you can see, the numbers are here, but the manganese is 7, and the oxygen, each oxygen is -2. Now this is pretty easy to divide into 2 half reactions. You see, this one goes with this one here, and these 2 go together. So what we're going to do in the next slide is I'm going to split these 2 half reactions up. So notice that the oxidation reaction looks like this, okay? And of course these are aqueous. So this has been split. Now it's oxidation because we're going from being +2 to +3. We're losing an electron here. So this is the oxidation half reaction. And then the other half reaction is the reduction. So let me go ahead and partition it here. And that one looks something like this here. And we got, if you recall, the manganese went from being +7 to only +2. It became less positive. Therefore, there was a gain of electrons taking place here. So this is your reduction half reaction. Now the next step, which will be step number 3, we're going to balance all elements that do not include hydrogen and oxygen. So we go back. This one's already balanced because there's 1 Fe on each side, and this one's already balanced because there's 1 manganese on each side. So we pretty much have this one taken care of. Now we're going to balance oxygen by adding water to the opposite side. So if you look here, there's no oxygen on the oxidation reduction, so there's nothing to do. However, notice that in the reduction reaction, there are 4 oxygens. So what we're going to do is we're going to add 4 waters to the opposite side. So it'll look something like this after you add the waters. You got the manganese here, and then you're going to add 4 waters because there are 4 oxygens. You add a water per oxygen. You do that to the opposite side. Okay, so that takes care of the oxygens. Now, by adding the water, we got to fix the hydrogens. So because we're in acidic conditions, we're going to add hydrogens to the opposite side of the waters. You see, there are 8 hydrogens when you multiply 4 times 2. So that means I got to add 8 hydrogens on this side over here. So now we have all the elements balanced, but we're not done yet. Now we got to balance the charges. We're going to go ahead and do step 4, which is balance each half reaction with respect to charge. So let's go back here for a moment. This side is +2 and this side is +3. What you do to balance is you're going to add electrons to the more positive side. That would be the +3 side. So in order to make this side equal to the left, I'm going to add 1 electron here because when you add that electron, that negative and the +3 make it equal to +2. Both sides are now equal. Now take a look at the bottom reaction here. If you look here, and let me erase this dash here. The left side, and we got to keep track of this, there's 8 positives here because each hydrogen is +1, but there's a negative. So the net charge on the reactant side is +7. On the product side, water is neutral, but this side is +2. So the more positive side is the +7 side. So if you're asking yourself, how many electrons do I need to add? Well, you're going to add it first to the more positive side, which would be the reactant side. And you would have to add 5 electrons so that both sides have equal charges. Now I'm going to go ahead and show you. Here is the electron that was added to the oxidation reaction. Here are the 5 electrons added to the reduction reaction. Notice the electron number is not the same. So here's where step 5 comes in. Now we're going to even them out. We want to make both electrons the same exact number. So to do that, what we're going to do is we're going to get equation number 1, or the half reaction, that's the oxidation, and we're going to multiply it by 5. So when you multiply by 5, you're going to multiply every single thing by 5. Okay, and that's what they're showing you right here. And you get 5 FEs, as you can see right here at the bottom, 5 Fe plus 3s and 5 electrons. Now, once the electron numbers are the same, here is the next key step. Number 6 is we're going to bring the 2 half reactions together. Okay, so we have here both half reactions. So what we're going to do here is, if you look carefully, you notice how they bring them together. They do this here. And I'm going to align this as best as I can. See how my spacing allows me. This is the first reaction here. This is aqueous. This is +3. And then I'm going to put the other half reaction down here. Notice how the electrons are the same, and they're on opposite sides of the reaction. Now, due to space constraints, I will do my best here to demonstrate this. So you got this here, and water's a liquid. So if you see anything, we're going to combine these 2 reactions. Anything that you see on opposite sides that are the same can cancel. Right now, the only thing that we can cancel are the electrons. Okay? Now, what's going to happen is they're going to combine everything, and pretty much that's the only thing that cancels. So look what ends up happening. These 3 will become the reactants when you bring the 2 equations back together, and you can see them here, here, and here. And then this one here and these two here are going to be your products, and you could see it over here as your products. Okay? Now, that is going to be the answer to our problem, but we need to verify to check if we did this correctly. So if you look here, when we verify, and we'll go back and forth here, notice that you have, and you know what I'll do here is, I'm going to go ahead and use a red check mark. Let's balance each element. So we got 5 and 5. Notice the arrow means they're on opposite sides. So the iron is good. Let's go back and check now. We'll go in the same order. We have 8 hydrogens here, and then 4 times 2 over here is 8. So that one's good as well. Going back, 1 manganese over here, and 1 over here. So that one is also good. Then it says 4 oxygens. Well, let's take a look. We got 4 right over here, and 4 times 1 over here, that's 4. So our elements are good, but we're not done there yet. We also have to verify the charge. All right, so take a look at this. Here is how we verify these charges. Let me go ahead and erase here. And we got to keep count of this because there's a lot of charges going on here. On the reactant side, that's 5 times 2. Okay, so that's 10 right there. I'll write it up here. 10 positives. Okay, so that's 10 there. Plus another 8. 8 times 1. That's 18. And then there's a negative 1. So you're going to subtract 1. So the net charge on the reactant side is plus 17. So we want the product side to also have 17. Well, let's see. Here, you got to multiply 5 times 3. And I'll do that down here. That's 15. Plus 2 more positives. That's 17. And water's neutral. So both sides have a plus 17 charge. Okay? Let's take a look at another example. So let's balance the following redox under acidic conditions. Again, if you assign oxidation numbers, okay, I'll use a red color here. This is -1. Diatomics are neutral. You can see the answers down here. Okay? This chromium is +3 because it's a monoatomic ion. Here's how they got the chromium in dichromate. What they did was they called the chromate chromium X, but there's 2 of them, so it's 2X, plus the 7 oxygens that each have a -2 charge, and then they equaled it to the charge. And when you do the algebra, which is what I'm doing right here right now, I'm going to solve for X, you get 2X is equal to -2 here, plus 14. -2 plus 14 is going to be 12. So X is going to be 12 over 2. X is going to be 6. And that's what you see right here. So the chromium is +6. And we know the oxygen is -2. Now notice how they already divided them. You know that these two go together. And these two go together. So the first step is we assign the oxidation numbers. And now we split them into oxidation and reduction. Remember that iodine went from being -1 to 0, became more positive. Remember that chromium went from being +6 to only +3. It became less positive, so it gained electrons. Okay? So now that we have the 2 half reactions, here's what we need to do. First, balance elements that are not hydrogen or oxygen. So if you look carefully, there are 2 here and only 1 iodine, so that's why they put a 2 here. So that's balanced. Now let's do the reduction one. There are 2 chromiums here, but only 1 over here, and that is the reason they put a 2 there. So now the elements are balanced, so we'll put a little check mark. Then, let's balance oxygens. Well, the oxidation reaction has no oxygens, so we're pretty much done with this one. But there are 7 oxygens here, so we got to add 7 waters on the other side. And now the oxygens are balanced. let's continue with our checklist. Now we got to balance the hydrogens. Well, the oxidation reaction has no hydrogens, so that one's completely done. But notice that when we put the 7 waters, we have 14 hydrogens. So we're going to have to put 14 hydrogens on the left side to balance the waters, okay, or the hydrogens in the water. So now we have these two balanced. But remember, after you balance the elements, we have to balance the charges. So here's how we do this. Remember that we had put 2I gives you I2. This is 0, and this is 2 times -1. So this side is a net charge of -2. Okay? And the other side is 0. So to balance this, what we're going to do is the more positive side is the side with the 0. To make it the same as the left, we have to put 2 electrons, which is what they did right over here. Now we got to balance the reduction reaction, okay? And here's what you do. Let me show you from scratch. There's 14 positives here and 2 negatives. So the net charge, 14 positives and 2 negatives, is plus 12. This is 2 times 3, so this is plus 6, and this is neutral. All waters are neutral. So the more positive side is the reactant side, and in order to make both sides the same, if this side is plus 12 and this side's plus 6, you got to add 6 electrons. So notice they added 6 electrons to this one. Now notice the electron numbers aren't the same, so that's where step 5 comes in. In step 5, what we're going to do is we're going to multiply the first equation by 3 because you want the electron number to be 6 on both sides. So when you multiply by 3, that means you're going to distribute the 3 to everything in that equation like you see here, and you get 6 iodines, 3 iodine, the diatomic form, and you get 2 times 3 is 6 electrons. Now they both have 6 electrons. Now we got to bring the 2 half reactions together. So notice anything you see on opposite sides, we can cancel. So the first thing you're going to see is that these 6 electrons cancel. As I look, I don't see anything else that cancels. So watch how I bring everything down. This comes down. The hydrogens come down. These are all your reactants, and the dichromate comes down. Now look at your products. This one's all the way over here. The 2 chromiums and the 7 waters. So now it's verification time. So let me erase this to make it a little bit more clear. And we'll go in the same order. We'll start with the iodine followed by the hydrogen. There are 6 iodines over here, as you can see. And you got 3 times 2 is 6. So the iodine is a good to go. Now it says hydrogens is next. So there's 14 here, and then 7 times 2 is 14. So that's good to go. Let's look at chromium. There's 2 here, and remember that 2 that we put there, so there's 2 there. That's also good to go. That leaves us with oxygen. There are 7 here, and 7 times 1 over here. That's also 7. So the last thing we need to do is to balance the charges. So let's take a look and see if they're balanced. There are 6 negatives here, 14 positives here, and 2 more negatives here. Remember, that's 14 times 1. So when you add this up, this side is going to have a net of plus 6, I believe. Okay, you got 6 and 14, that's plus 8, minus 2 is plus 6. So the other side needs to be plus 6. Well, guess what? This is neutral. This is 2 times 3, this is plus 6. And this is neutral. So this side is also plus 6. So that would be your balanced equation. Okay? All right, let's try another one here. All right, so let's balance this one. First thing I'm going to do, let's assign oxidation states. This is a 0 here. It's an element. This is +2. Let's find out what the N is in NO3. So let's put X plus 3 oxygens times -2 is equal to -1. So X plus -6 is equal to -1. X is going to be -1 plus 6, which is 5. So the nitrogen is a +5, and the oxygen's a -2. Now let's check out NO2. So we're going to call nitrogen X again. There's 2 oxygens, each at -2, and we're going to set this one equal to 0 because it is neutral. And when you do the math here, you get that X is +4. So over here it's +4. And oxygen is still -2. Now clearly, when we break this up, that's one equation. And these two are going to go together. So I'm going to go ahead, I'm going to erase this part since we already have our oxidation states. And I'm going to follow the steps that I showed you previously. Okay? So first, copper is going from 0 to +2. So copper is the one undergoing oxidation. It's losing electrons. And then NO3, okay, and this one, I'm going to ignore the states of matter for now just to save some space. It's going to NO2, and notice that the nitrogen's going from +5 to +4, so it's gaining an electron, so this is your reduction half reaction. Now, let's follow the rules. First, balance any element that's not oxygen or hydrogen. Well, this one's already balanced, so this is good. And this one's already balanced. So now we're going to go and balance oxygen next. Well, this one has no oxygen, so that one's good. But this one has 3 oxygens on the left and 2 on the right. So I'm going to need to add a water here so that both sides have 3 oxygens. So now my oxygens are balanced by adding the water. Then here's what I'm going to do. Now I'm going to balance the hydrogens. By putting that water, I have 2 hydrogens. So you're going to go back over here and put 2 hydrogen ions like this. Okay? Remember that the ions are all aqueous, just so you know. Okay, so now all the elements are balanced. So now we got to balance the charges. Well, this side is 0, this side's +2, so the more positive side is the copper side. So look what I'm going to do. I'm going to add 2 electrons here to balance the charges. Now take a look at the reduction reaction. This is +2 here because there's 2 positive hydrogen ions. Here's a -1, so the net charge here is +1. This is neutral and neutral. So the more positive side is the reactant side. And in order to make both sides equal, I'm going to add 1 electron over here. Just like that. Okay, now I'm going to erase this for a moment. And now comes a very big step. And that step is to balance or to make the electron numbers the same. So what I'm going to have to do is I'm going to have to get this equation and I'm going to have to multiply it by 2. And when you multiply this by 2, you end up getting 4 hydrogen ions plus 2 NO3 negatives. Here's the 2 electrons that we needed. You get 2 NO2s and 2 waters. Okay? So, now that we have that, our next big step is going to be to bring these 2 together. Okay? So let me go ahead and I think I should just, now that I did this, I'm going to erase this part here. And I'm going to bring the 2 reactions together. So I'm going to combine them. And if you look here, I'm going to put this one right above here. And look what's going to happen. These are going to cancel because they're on opposite sides. Now, I don't see anything else that cancels. So here's what we got to do. We need to bring everything together. So your reactants would be your copper. Okay, technically it's a solid. Your 4 hydrogen ions, which are aqueous, your 2 nitrates, which are also aqueous, and then on the other side, you got copper ions, which are also aqueous. Okay, these are all your products, the 2 NO2s and the 2 waters. NO2 is a gas, water is a, sorry about that, it's a liquid. Okay, so let's see if we can verify. I got 1 copper here, 1 copper here. That one's good. 4 H's here and 4 over here, we're good. I got 2 nitrogens here and 2 over here, we're good. I have 6 oxygens over here, and there's 4 over here, but 2 more in the water, so there's 6 on both sides, so we're good. But now we got to verify the charges. So, copper is neutral, okay? There's a +4 over here, and a negative, see there's 2 here, so it's a -2. So +4 and -2 gives you a net charge of +2 on the reactant side. Now on the product side, I got 2 positives here, and water and NO2 are both neutral. So that side is equal to the opposite side, and you have +2 on each side. Now let's check here. We got our answer here, okay? And notice when we verify everything, you will see that the charges do add up. They're +2 on both sides, okay? Now, here we have another redox. Now what I'm going to do is I'm going to help you get this one started. And then I want you to try this one on your own, and then we'll check it, okay? So here's what we're going to do. When you do this, remember these 2 are going to go together and these 2 are going to go together. Divide them into an oxidation and a reduction reaction, okay? So when you split this up, you're going to go ahead, and we know that these 2 are coupled together. These 2 are coupled together, okay? You're going from 0 to +2 here, so this is definitely your oxidation. You're losing electrons there. And then if you remember, this one's +7, this one's +2, this one's gaining electrons, so here's your reduction. So what I want you to do now, follow the steps, balance the elements first, followed by oxygens by adding water. After the water is added, then fix the hydrogens by adding hydrogen ions to the opposite side. After all elements are balanced, then your job is going to be to balance the electrons, then make the electrons be equal for both half reactions before you bring the 2 reactions together. And then when you merge them, see if anything on opposite sides cancel out. And then verify not only that the elements are the same on both sides, but that the charges are the same as well. So I want you to pause the video. I want you to try this one, and when you're done, I'm going to provide you with the answer. Okay? So this is the answer that you should have gotten. Okay? You'll notice there's 5 tins, 16, 8 times 2 there is 16, 2 MNs, 2 MNs. You got 8 oxygens here, 8 oxygens here. Okay, and then the charges, you have a +16 here and 2 negatives here. So the net charge here is +14, okay? Over here you got 5 times 2, which is +10, but you got 2 times 2, which is +4, and this is neutral, so you also got a +14 here. So that's how you balance the charges. Okay, so hopefully you did this one correctly. In class, we'll continue doing more, and in our next video, I will show you how to balance redox reactions under basic conditions.